This video will be about solutions, which is basically a situation where we take a solvent, which is usually a liquid, water, and we dissolve and mix another substance with it, usually an ionic substance, but it doesn't have to be. We'll talk about particular examples. The main thing is that some things dissolve in a particular solvent or they'll dissolve in another solvent. And so how do you know which things dissolve in which solvents? Well, basically the solvents you're familiar with are water, and you probably have an idea of some things that dissolve in water, like table salt. Sugar dissolves in water. The other class of compounds is things like gasoline, oil, and those things don't dissolve, ionic compounds like salt or sugar, that well. And so the driving force for things to mix is whether they actually are attracted to each other as much as they are to themselves. So for example, when we say like dissolves like, a polar compound dissolves polar, all right, and charged. Okay. So for example, we have water, the molecule. It's bent, and it has a partially negative oxygen, delta minus, and partially positive hydrogen atoms. Okay, so that means it has a dipole moment that is in that direction. We draw the dipole moment, of course, with an arrow with a plus sign on the positive end and the arrow pointing in the direction that electrons are being pulled. All right, and so what that means is any other substance that also has a dipole moment, okay, whatever it is you're trying to dissolve, if it has a dipole moment, this interacts with that by the negative end being attracted to the positive end, and the positive end of this one being attracted to the negative end of that one. So that's why polar molecules dissolve other polar molecules. Okay? So if there's no dipole moment here, then these more or less tend to stay with themselves, and of course these don't get dissolved. Now, ionic materials form ions when they dissolve. So when you dissolve sodium chloride, you get positive ion and you get a negative ion, chloride. All right, and so in the crystal, these things are next to each other, and because opposites attract, that's why they form a solid at room temperature. Okay, but the positive ion in sodium is going to interact well and be attracted to the negative end of a water molecule, so this will actually come out of the crystal and be surrounded by water molecules with the negative end of the waters closest to the sodium cation. Okay, so I'm just not going to draw the hydrogen atoms in water explicitly. Okay, and so that's why ionic materials generally dissolve in water. We'll talk about the exception there a little bit later. Okay, now when a substance dissolves in water into ions, it will actually conduct electricity. And so this is called an electrolyte. Okay, and so you may be more familiar with the term electrolytes from the fact that Gatorade provides salt ions basically to be replenishing what you lose through sweat and other athletic activities. Or you may be familiar with Brawndo from the movie Idiocracy. All right, so now the chloride ion will be surrounded by waters, but with the partially positive ends of water. All right, and so all right. So that's why salt dissolves in water. Okay, now if we go to high charges, well, it turns out that yes, the high charged ions are attracted to water, but they're so attracted to each other inside the crystal that they don't dissolve. So basically there's lists of rules about what dissolves in water as far as ionic materials and what does not. But generally speaking, if you have a charge of +1 and -1, it'll dissolve in water. If you have higher charges, it generally will not dissolve in water. Okay, now what about nonpolar solvents, right? So with nonpolar solvents, things like carbon tetrachloride, that has no dipole moment, even though the bonds are polar, right? And so this is why Chapter 7 on the shapes of molecules is so important. Or was that Chapter 6? Anyhow, but the chapter on shapes of molecules is so important because that determines whether the whole thing is polar or not. So this has polar bonds, but they don't cancel. And so you have a dipole moment. This has polar bonds, but they do cancel, so this is nonpolar. So carbon tetrachloride would be a solvent that would dissolve other nonpolar materials like grease and so on. This is what they actually used to use in dry cleaners, but it turns out that this produces chlorine atoms in the ozone layer, depletes ozone, so they replace some of those solvents with other nonpolar solvents. Okay. And so this will dissolve other substances such as grease. So you can have, you know, some long chain hydrocarbon like pentane or something like that. Okay, this is nonpolar. So these two things will mix together. And so there's London forces between the molecules of pentane, and there's London forces between the molecules of carbon tetrachloride, and that means there's London forces of equal magnitude between the two different atoms, and so therefore they will mix.